little spaceship. These are like in the new M3s, the S58 engines. Quick turn, 250 MSY. I'm looking for better results, faster. Gonna get sleeved. We saved 2 hours and 15 minutes of cycle time. This is really the workhorse for us. I mean, it's like these are titanium valve spring retainers. So it's a huge variety.
Yeah.
These are Jaguar cylinder heads. Like,
boy, this is beautiful.
We flip this thing upside down. We put this face down on there.
Woo! Beauty. Boy, that's nice.
One of the older M5 engines, what they call the S62.
All right, so this is part 2 of the tour that we are doing here at VAC Motorsports. Now we're at the machine shop. We got lots of high-end equipment, and Tony's going to show us around, and we'll get into the nitty-gritty of the machining operation.
Here at VAC, we have a motto that we like to go by. It's quality first. You know, quality without compromise. Everything we do has to be done right. So that's why we have that sitting there. We had a lot of light coming in. It was actually too bright. So I minimized the windows at first, but it was still too bright. So I figured the next best thing I could do is represent our partners, whether it's our partners in manufacturing or the components that we sell.
Great lighting in here, though.
Yeah,
a lot of shops are dingy. This is a great feel.
We had LEDs that were converted from non-LED, and it wasn't the same feel. So we decided to just, go for it big time. I didn't want any dark spots anywhere.
Right.
Like anywhere you stand, it should be even light.
Yeah.
It's kind of
don't want to have shadows over your work when you're trying to inspect it or something.
Exactly. So what we have on this side, the way we've divided this front section is 6,400 square feet, not including offices, inspection room, or anything like that. But this floor space we decided for now, it's mainly on this side is the engine building side. Cleaning is in the back. And then on the other side, so this half is engine building, on that other side we call it like production alley. The process on this side starts with the cleaning in the back, goes on to the Centroid block machine and head machine, and then we move over to honing, line honing and cylinder honing, and then cylinder head, and then we come back to the assembly area. So it disassembles, goes to cleaning, and then goes a loop again.
Okay.
That's how we've organized that. So let's go on the production side. You can see here we also have a 3D printer as well. We do some of the parts that we can print as a prototype. Just get a quick idea, do we like the way it looks? Whatever we can print, so that's there as well. That has a pretty nice work envelope. The Grob obviously is going to be, I'd say, 2 machines are the featured machines. You got the Grob and then the Integrex.
Yeah, for people who don't know, this is a super high-end 5-axis.
Yes. Super accurate, and when it's working, it's kind of like poetry in motion. It's like ballet. You literally, if you didn't hear the coolant pump and you didn't see coolant coming out, when the axes are moving, you kind of can't hear it. When the spindle's turning, how the spindle turns up to 16, and then when they apply the brakes on that spindle, it goes like from 16,000 to 0 almost instantly. It's just phenomenal.
Yeah, good engineering.
Yeah. So let's see if we can just open the door and show you a little bit. So we have some shunt work holding in it here for the last job that we just did. And we kind of walked through the panel. So we kind of created a pallet, and then we just made this little stand here for when we're working. We don't want the part to fall over, so we just kind of do that.
Those are 0 points.
0 points. And then they just kind of lock in, drop in. These are manual, so quick quarter turn, lock, unlock. And then we're changing out one to the other. So that kind of worked out really nice, this type of setup. And the part that we made on that were these.
And what is this?
This is a billet oil filter housing, so it allows you to take off the factory oil filter housing and go on with this setup that gives you additional ports for whether you're doing wet sump or dry sump, but then you get full filtration through your filter system. OE filters still bypass some of the oil. So if you have a performance or race engine, you really want to try to filter 100% of the oil. You know, our little spaceship,
So
117 tools.
Oh, wow. Yeah. Why did you end up going with the Grob versus, I mean, there's a lot of 5-axis machines out there.
Well, you know, I love the horizontal spindle concept. I love the fact that you can rotate, you can machine upside down, but even if you're not upside down, you can machine and you're horizontal and your chips are always falling. So this one, the reason it's sitting here, we have to make more, but I want to transition it to the G350. We were doing it in the vertical and the Okuma, which is nice, but it's usually laying down like this, and these are pretty deep pockets.
Right.
We do this side first, so there's no drainage. And then you're kind of machining and you can't tilt your tools, and so your finishes they're nice, but they're going to be nicer when they're done in a machine that you can actually tilt the tool away a little bit.
Sure.
And it'll be machining, even if we did the same exact process, it'll be machining like this, and all the chips are falling out instead of grinding the chips back in, remachining chips.
Not to mention it's going to be way faster on this than that, right? Just because
it's going to be, because right now what we're doing is we're doing op 10 like this, and then we're putting it on a fixture and we're doing this. So the concept with these is that we'll be able to spread these out a little bit, and then we'll just pre-drill and put our ball studs right in here. And we'll be able to machine every single edge and every single feature,
right.
And then we'll probably just end up just leaving tabs in the end.
Yeah, just break it off.
Snap it off. And it's either you'll dress them manually, but if I want it perfect, then we can just put it down with 2 bolts and rip one pass, finish pass on an edge.
Yeah, on a vertical or whatever.
That's it.
Yeah.
So that's kind of the goal with this. But yes, the machining, I'm looking for better results, faster. So we're probably going to look at doing engine blocks in here, but the 6-cylinder is a little too big for the G350, so we're probably going to have to do that in the G550. We'll see if we get there. When we go to do the blocks, you can do tool change. You can put boring bars that are very long. I think you can, going from memory, I think a G550 can tool change about a 24-inch length tool. So you're talking about you just orient your engine block, and you can go through the mains from one side all the way clear to the other.
Oh yeah, right.
So the worst case scenario, it's a very accurate machine. We go a little bit more than halfway, and then back out,
right.
do a 180, and come in and do the others. So
yeah.
That's probably how that's going to end up happening when we do those. So there are some of the key features. I mean, you're going to want to know that you're on an absolutely precise machine to do that kind of job.
Yeah, how do they, you have special machines for boring the crank?
When we
right?
line bore, yeah, I mean right now, I can show you some billet blocks that we made, but what we do with those is we put the caps on and then we set it up on a line boring machine, right. And then you have to go in and line bore it, and then we line hone it afterwards.
Yeah, and to be able to line bore all in one
just
setup.
Get it the final size in here.
Right.
That's going to be a significant savings in time. I'd much rather hit cycle start and see a boring bar come out, just go through, even if, like I said, even if it's just past halfway, past the middle, and then back out, do 180, come in and hit it again. That's what I think we'll end up doing. But you know, the ability to even some of the things that are actually just that only need a 4-axis machine. This machine has enough height that if we were to put a tombstone on it, you could actually do the same thing you do on a horizontal 4th axis, you know?
Cool.
And then if you had to tilt to do some features, you could actually do it without any problem.
Sure.
Yeah.
Yeah, neat.
So.
Yeah, cool configuration. For my day job, I sell CNC machines for Campro USA. I'm just going to put in some quick clips here of what people's experience are with the Campros. And if you have any interest, reach out to me. Appreciate you watching.
The longevity of the oldest ones we had is just indestructible. They're bulletproof. I mean, virtually no maintenance. You know, just the common maintenance of keeping up, because I truly believe in them.
Yeah.
I believe in the ownership. I believe in the machines, their capability, their quality. No, the Campros have treated us good.
So I think we have 5 Campros altogether. Since they're good running, reliable, accurate. Yeah.
Have you had any major issues with them?
No, nope, not at all. And these are affordable machines too, so that helps.
You have Campro, Doosan, Kitamura. How does the Campro stack up with the other big names?
Oh, it's good.
Yeah.
For sure.
Yeah.
Yeah. I mean, we haven't seen any, quality or reliability issues.
Accuracy.
Accuracy is good.
Yeah, this machine is the latest that came in. Just a quick turn, 250 MSY. We're getting this set up. For this, we're going to use it for, you'll see some manganese bronze rod on the bar loader over there. So that's for making valve guides. It does have live tooling, but the intent is not to take the work away from the Integrex. It's to take the work away from the Integrex that's so simple that it could be done here faster.
So the MSY, does it have a sub and a Y? Is that the SY?
Yeah. Yep. So it's sub spindle. Like this machine is an 8 and a 6.
Yep.
And it's set up with collets right now, and we do have the original chucks for it if we decide to. But again, the goal is to just do smaller work with it. This here is a piece of titanium. We make some titanium retainers, valve retainers. So I think those will end up getting moved to here because they get done in there and they get done nicely. But again, tool change time is slow on a mill turn. That doesn't have a lower turret. If it had a lower turret, it would be a slightly different story.
Right, sure. What do you have for Y travel on this thing? It's not a very tall machine, so.
It's not a very tall machine.
I
I
open this
think
up?
I think we're gonna have to power it up.
Don't worry about that.
But the Y travel on this, going off the top of my head, I think it's about 2.5 each direction. So it's pretty decent.
Okay.
You know, 2.5 each direction. It's
So is
pretty
it the
decent.
sliding wedge style?
Yes.
Yeah.
Yes. And that's kind of what I like about the Integrex when we get there. I've had this since 2015.
This is the bridge style Genos, right?
And this guy has made a lot of parts, including, it's roughed out some of the billet blocks that we'll be showing you as well. When we first did the roughing on those blocks, we started out with 400 pound, 393 pounds of aluminum. And the first time we ran it and smoothing was still turned on. So we ended up with about a 4-hour cycle time for both sides, which was not bad. But, what would you think happened when we turned off the smoothing and ran it proper roughing speeds?
I think you could double your cycle time, or
half it. Yeah, we ended up with 1 hour and 45 minutes.
Yep.
We saved 2 hours and 15 minutes of cycle time.
Yeah, I mean, all those little arcs, it had so many points, right, with the smoothing.
Yep, it was pretty phenomenal. But this is 15,000 RPM spindle.
Good for aluminum.
Yep, good for aluminum. When they started making these machines, you only had 32 tool capacity. I love the control. I love how you tool management and the control. Super nice. This is the machine that I've used the most, and the second machine that I've used the most is the Integrex, the Bartac.
What's the trails? I'm guessing 50
This is
by 30
it's basically a
or something?
40-20 machine.
40-20, okay.
Yeah, 40-20. And it is, it's wired for a 4th axis, and we do have a 4th axis. You can see where the imprint is for the 4th axis.
Makes sense.
Yep. And then we barely put this into the work column, just enough to be able to probe.
Right.
And we built our own little guard for it.
Keep the chips off it.
Yeah, because when you're really removing material, like we do a lot of material, it tended, like we didn't pay attention initially, but I guess all the chips hitting that eventually just moved it just a little bit and made the tool touch-offs not as accurate. So I said, okay, well, we'll kind of address that and fix it.
Sure.
But it's been a workhorse. It's been a solid machine.
Nice.
We go on to the Integrex. This is really the workhorse for us. I mean, this does the biggest variety of work. If you had to have this Swiss Army knife, a mill turn would be the Swiss Army knife in a machine shop. Yeah. You know, we could always, if we had to, we could always do a little demo on the Mazak Troll, but you know, at another point in time. But it's pretty powerful.
I would like to
Seeing
see
is
that
believing.
sometime, yeah.
Seeing is
Yeah, I've
believing.
talked to a lot of people who are strong believers in the Mazak Troll, so I would like to see that.
We have 72 tool capacity over here. There's 36 on each. So we have 72 tool capacity. From turning to milling, we have some of these tools set up as combos to where we go in here. You know, this is the 35.
Right.
We have one that's set up as, so that the 35 is kind of a specialty. We have some of the doubles. One is in there. That's a double.
Yep.
So that
Both
will,
sides.
yep,
So you got,
that will roughen. So we put an 80 and a 55 in here.
right, so the
A lot of
CNMGs and the DNMGs.
Yeah, so
Right.
we do that, and we don't have to change inserts. You know, we just call up the job, the right tools in the machine already. That works out really nice.
Yeah, so this is essentially a lathe and a mill, so a lot of
Well-
times you would have to have a mill op and a lathe op. This can kind of do both.
Yeah, what I like to clarify for people, because technically, some people want to call that MSY a mill turn,
Right,
but it's not really a mill turn. It's actually a turn and then a mill.
Right.
Right. So it's more turning than milling. You have some live tools. You can do milling.
yeah, you need to do a flat or something.
Is actually, yeah, this is actually meant to be more of a mill. Especially specifically, even this more so, because this is the Bartac-S, so this has 4-inch bar capacity on the front. It's really meant more for medical, where you're doing joints and this and that. You can full 5-axis movement, so you can. This is what this machine's really meant for. But for us, it works because we can run parts this size. We can run up to 4-inch, and we can bar feed if we want.
Oh, nice. Do you bar feed these parts?
Bar feeding these, and then I just could not come up with a method to make the part out of all the inserts. We struggled to be able to part it and get a lot of parts with the parting tools. Everything else
Okay.
we got to hold up. We couldn't get more than like 12 to 15 parts out of a parting tool,
Yep.
no matter what we tried. We tried Y-axis, we tried everything. So finally I gave up. So we'll just go. Plus these are really, I want everything QC'd, every feature's QC'd, so I want somebody to touch every part.
Yeah.
So we just, we saw cut them and we load them one at a time.
Sure. Yep.
Yep.
Neat.
Job like this is a perfect candidate for automation with a cobot.
Right.
So when we're doing smaller parts, so parts like this, you know, these spring seats, these are all just unloaded with the unloader. But you could imagine, like, this is a 2-minute part
Yeah.
in here.
Sure.
Do it in there, it's probably a 40-second part.
Right, because the tool changes 2 seconds versus,
Yep.
what were you saying, 15 seconds?
Yep, and these are like, but it gives us the ability, I mean, we love it. It's like, these are titanium retainers, valve spring retainers. We do these in different sizes. These are like the 8mm version. We have some over there that are probably like the 5mm version, very small. Yeah, the Swiss Army knife, these are obviously anodized, but every single one of these is created on this machine. I mean, I could show you a variety of parts that are all made on the same machine. You know?
Right. That is quite the
That's-
variety.
Yeah, so
And-
it's a huge variety.
Yeah. And you could make parts that have really no round features. I mean,
Right.
it works just fine.
And we do have those. You know? But it's pretty impressive, the variety of parts. Like this has some round features obviously, but it's got the milling. But this, one could argue it might be faster in there. I don't think so. There's enough milling in this between, you know, all the
Yeah.
features. So
Yeah, that's
one
probably
could argue, because
3
this
live
is
tools, right?
12,000 RPM spindle when you're milling.
Right. What do you have, like 6,000 on the?
6,000.
Yeah.
But this is, you know, this is like on a job like this is where the accuracy comes in, by the way. Like these are milled. These aren't hobbed, these are milled with an end mill. All right, same thing with these. These are 4140 heat treated material. And these are all milled.
Do you have to send those out and then bring them back after heat treat, or you
So they're heat treated and they're done.
right away? Yeah. Preheat. Yeah.
They're heat treated, they're done. You have the next step, it'll go out for the internal spline cutting. That's specialty work and we don't have that.
Now is that done with a EDM? Or
No,
like
no. We have special cutters that were made because this is like a certain. There's certain features in there with this helical.
Huh.
You know,
I'm trying to even
this
picture
was very,
what that would look like to
Yeah.
cut.
It's very. I could never understand it, but I had it analyzed a few times, and they're like, no, this is specialty work. So we had specialty tools made, and they only cut so many pieces before they have to go back out and get sharpened again. But
Interesting. I'd be curious
Yeah.
to see that process.
Yep. Then over here on this side, right now this machine is powered off, but you can see there's a tombstone on this side, and then on this side we took out the tombstone because we're doing the end features of the cylinder heads.
Oh, cool.
These are Jaguar cylinder heads, and they come in as raw castings like that.
Yep.
We probe, we get the average, rotate, get what we need to do, then we face it down after that, then we start putting in all the face features. Then it flips onto op 20, which is basically a bolt-on, and that locates everyone in the same place. They all will locate the same way. Then that's when we go in, and if you go back to the side here, you'll see that's where like the intake features and the exhaust features are done. That's when we do those features for the cam lifter bores, stuff like that. All those are done on the op 2. And then op 3 is when we lay it down and then we machine the front face and the back face.
Cool.
So that's a little bit of a lengthy process, but I mean, it's a
Yeah.
casting. There's a lot to do there.
Most of the times, I don't see horizontals used like that.
We're a high mix, low volume shop.
Okay.
So we're trying to use, if you notice, there's like a bunch of different fixture plates that are made, and so on the tombstone, we created our own patterns on the tombstone. So these fixture plates will fit using shoulder bolts, so they will repeat every. So let's say we're doing one job that's going to be running for a while, and we want to do a job that's a smaller job. Instead of taking one big fixture plate that's the size of the whole tombstone, we just have them done in quadrants. So we just take one of the quadrants off, put that on, run that small job,
Okay.
and it'll be hard coated and everything, so it'll be quick. Once it's done, bounce back and go back to the job, resume the job we're doing.
Okay.
So we even have a pattern on the side of the tombstone. So if we're doing smaller parts, we can load the tombstone. But we don't do anything that's like thousands of parts. We could,
Right.
and you know, maybe we'll start entertaining some of that work. But a machine like this kind of needs it. If we can't turn into that type of shop, or if we don't want to turn into that type of shop, I think, you know, having the tombstones with this type of fixturing makes us flexible enough that it's not the end of the world, you know?
Yeah.
Now, the other thought is that, do you move away from a horizontal machine like this, and then you end up coming back in with another 5th axis or 5 axis machine? Because now you could throw anything at it, and you could use the 5 axis like the 4 axis if you have to.
Sure.
Or you, like this machine, the reason you see all the space between it is on the Grob. This is automation ready. It's pallet ready. So we left the space that if we wanted to put a 10 pallet system in,
Right.
we can.
Nice. So when you purchased this, did you have like a big running job that you thought you might want this for, or just wanted the four axis capabilities for?
Yeah, I wanted to do like the engine blocks. So the
Right.
engine blocks that here's some Billet engine blocks to see.
I was looking at those. Those are beautiful.
Right. So they were finished in the Centroid, but they're the ones that were roughed out in the Okuma.
Right. So this started as just a big chunk of aluminum.
Started as a big chunk of aluminum. We went a little bit more than halfway down, and then we flipped it and did the other side. And then after that, we had fixturing. They did go out for a heat treat in the middle, in between, because there was a lot of material removal. After they came back, then it was back to the Centroid, face one end, flip it, face the other end, you know, put those features on. And then basically you have fixturing for the two ends, so it went right into the rotary, and everything was done on that 5 axis. So you look at all that, and then that can easily fit in that HCM. And there's only one feature on this engine that truly needs a 5 axis machine.
Oh yeah.
And it's this port over here.
Okay.
Because that comes from the top
Right.
and then comes down to over
Right.
there. But other than that, you could really do just about everything else.
Boy, that's a bummer. That's just one feature.
Just one feature, which is okay because if that's all you have to do, then you just
Right.
set
Quick
it up
op.
and
Yeah.
makes it go quick.
Yeah. No, you're never gonna be producing
You're
thousands of those.
No, no. We're going to have a lot of rigidity in the horizontal, and that was the thought process. So it was really to be able to do blocks, and you know, again, it's like this block here. These will probably start to become billet blocks at some point. Right now, people are still using them. These are like in the new M3s, the S58 engines. So this S58 block, in factory form, like before you start building them, they can get close to 1,000 horsepower out of these things with just like bolt-ons. But once they start pushing that threshold, now that's when they start having issues. You know, at that point, we're doing pistons, we're doing connecting rods, we're doing other work. And if they overheat, then these tunnels, the main bore over here can go out of whack a little bit. Like I have a customer who didn't check it, and who didn't say check it, he didn't tell us the block was overheated. So we did the sleeving work, we did all the work for him, and he just called me. He said, I think the mains are out of whack, so I want to bring the block back. He's going to bring it back for a line bore.
Oh,
But it would just been nice if you said it was overheated and check the main. So that's what happens. You overheat engines, you could start have distortion. You know, this is a pretty long block. What the billet will allow us to do, you go in here where you have this cap, and then you could add more material, and then when you make your own caps, you could make them to where, here, I think you can see over here, so we can turn it into a 4-bolt main. So if I remove these guys, and then you can see how those mains are done, you see?
Right.
So there's support with 4 bolts, and then it's supported on the side. So that's pretty open, and you only have 2 studs, 2 bolts holding over here. So you could have a lot more movement and deflection, whereas that design is a lot more rigid. So really the big thing for us is everything I tried to do with the latest equipment, this is automation ready because they can actually add they can add I think like 5 or an 8 to this easily.
Yep.
Field retrofittable.
Tombstone pallet pull. Yeah.
Yeah.
Yeah. Cool.
So like both were purchased with the ability to field upgrade.
Nice.
This thing is specific to this Integrex too, because that bar loader will do it can do the 4-inch bar,
Yeah.
but it's pretty deep as you could see as well, so you can get a lot of material
Right.
in here.
Yeah, it's a beefy bar feeder.
Yep. Pretty cool spindle liner setup.
Oh,
That's
yeah.
what we have.
Now these are all steel.
Yep.
Yeah.
Yeah, I don't like your they swell, and you know I had an issue with it in the LB when we did one, and like it took 2 good people like 3 to 4 hours to get that spindle liner out.
Really?
It was really pretty locked in. After
Jeez.
that, I said never again. So
Yep.
when we got this machine, I did these are the burns steel.
Yep.
And if your bar loader slides to the back, then you can do these, and then they also have segmented ones. So if your bar loader has to slide axially with the spindle, they make segmented ones to where you can load
Okay.
certain
Interesting.
pieces. But in my opinion, that's the only way to do it.
Yeah.
is-
I've never
is with
seen
the
those
steel.
segmented ones.
Yeah. Yeah.
So this is a kind of a unique 5-axis machine.
This was, from what I understand, was designed after like a Cincinnati 5-axis, the early Cincinnati 5-axis, where they had a head like this. So this can only go 60 degrees. There is a version that can go 90, but it's not with that ball screw. It's geared inside.
Right.
So on this one here, that's about the limit, 60 degrees.
So is the ball screw for accuracy reasons?
I think it's just to support the weight as well.
Okay.
But I would imagine if you're driving it with a gear and a servo or anything in the back, it would have to be pretty big, and this is a lot of weight hanging up there. So probably this way it gives them pretty good accuracy. I think they went to the 90, but they're also bouncing back to the 60 because if you don't need the 90, this is pretty rigid and pretty good.
So what are you doing on this block here?
So on this block here, it's going to get sleeved. So it's been, you can see the finish, it's been resurfaced already.
Now do you have like
And
a
then we
PCD
bore.
cutter to hit that surface?
Yeah, you like that finish.
Yeah.
So we had to do that because when you go in with the sleeve and you're hitting two dissimilar metals, the finishes weren't so nice. So yeah, that's pretty nice. So the next step will be we'll cut counter bores, and then the sleeves can drop in because let's see here, it should have a sleeve somewhere close by or another block that I could show you. So these sleeves are a little bit different, by the way. These are designed for that. This is called a wet sleeve. So the whole cylinder doesn't come all the way up, but what happens is these will drop down and the block will be finish machined to this exact size. So this will drop down, it'll support here, and then the flats support each other going down the block.
Mm-hmm.
But the sleeve that we're going to be using in there is a flange cylinder sleeve, and it's merely just goes like this diameter all the way up and just has a little step. And that's what we do for those because most of the power upgrades, that's all they really need. So that's going to get counterbored and sleeved next. And as we go down, we'll probably see something that's been sleeved, and then we can show you that. This machine is specifically for just handling and grinding the valves, dressing the intake and exhaust valves. So we recondition them on this machine.
So you would take off all like the carbon buildup and that kind
Now,
of thing?
after all that cleaning is done, if there's a lot of carbon that doesn't come off, we'll use the wet blast cabinet and blast all that off. But once the valves are really clean and everything is nice, there's a chuck in here that's operated by air, and it's basically, you know, like just 3 check balls in there that grab the valve stem, and so they have 2 sets of them. Grabs it, keeps it spinning concentric, and then you can change the angle of the cut. So if it's a 45-degree face on the valve, you can cut 45. If it's a different angle, you can just recondition that. And after you do the face of the valve, you typically do the back end of the valve, the tip, and that's where you stick the valve in here, bring it over, lock it in, you set it against the stop, and then you swipe it across the stone over there.
Neat.
And then this is for doing we were talking about the mains over there. How the mains can work.
Oh, the line bore?
Yeah, so this is a line hone. So after you line bore, you leave a little bit because honing is technically a little bit more accurate. And so then you would attach this line hone and you would go through, this long Sunnen mandrel would go just through all journals and then just get everything to one size.
Now honing, you're actually getting to a size? I was thinking you were just, it was a surface finish thing.
No, we leave about a thousandths.
Okay.
Because when you bore, you're leaving like peaks.
Right, peaks and valleys with the whatever nose radius, right?
Exactly.
Yeah.
So with this here, you just kind of flatten them out, just makes it a better finish.
Okay.
So if you look at this block here, this has been sleeved, so you could see what the sleeve looks like.
Boy, this is beautiful.
And what I tell my guys to look for is if you look on the angle, you'll see the rainbow, you know?
Right.
When you can see the rainbow, you know you have a good finish.
Now, isn't that some like optical phenomena or something with light refraction if it's super flat?
I think so.
I think I heard some sciencey thing about that one time.
You'll see it in aluminum and you can see it in steel.
Right.
You'll see it in both.
Yeah, any material that has like a really nice face on it.
So yeah, this is, and you can see a very small chamfer that we put on there. You want a little chamfer to help the rings when you're dropping the pistons in with the rings.
Somebody's gonna correct me and tell me I'm a dummy in the comments, but I think it has something to do with the wavelength of light. It starts interacting with the flatness of the...
I do have a cousin who has a doctorate in nanoscience, and specifically light.
Okay.
So if I wanted a dissertation on that, I could probably reach out to him.
Right.
So yeah, this is this Rottler machine here is the cylinder hone. So if we're doing the line hone, we flip this thing upside down, we put this face down on there, and we do the line hone. And then if we're doing the cylinders, then it sits down across here, and they clamp it down. And this is an NC hone, so it can move from cylinder to cylinder. It has a rougher and a finisher. So we rough with the diamonds, and then we finish, you know, with a different stone. And you could see the difference here. These guys versus these guys.
Okay.
And it will actually hold a tenth.
Oh yeah.
It will hold a tenth.
Wow.
It senses. It's got some pressure sensors. You know, once you get the size.
Wow. Now, are cylinder diameters held within a tenth? Like, would that be a normal tolerance for a?
For us, absolute max is 2/10 for us.
Wow.
Absolute max.
Now, what would like a factory tolerance be? Similar?
It's different. I mean, I would assume, because we never really take a brand new one apart
True.
and check it.
Right.
The other thing that we do is we put torque plates or honing plates on here. And I think there was one somewhere along there. There it is. So we put that on, and then we torque everything to simulate the stresses of a cylinder head. So when you go down with your fasteners are attaching pretty low. On some of the newer cars, on some of the older cars, the threads don't quite go as deep. So when you torque the head and you hone it, you're simulating round with a head in place. If you run an engine, if you don't, on the BMW specifically, but I know on American cars as well, if you don't use a honing plate and you finish your cylinders and you run the engine, next time you take it apart, you'll see almost in line with the stud holes.
Oh yeah.
You'll see a shadow.
Wear marks because
You'll see a shadow because it deformed. Yep.
Wow.
So that's why
Okay.
every job we do with a honing plate.
Interesting.
Yep.
Never would have thought of that.
Yeah, so then after we're done with the block, we come over to the cylinder head area, the valve job. This machine here, this Newen, is a really cool machine. This pilots, you put your cylinder head in, clamp it. It pilots off of the valve guides. There's probably a job over there we can look at, but it has a carbide pilot that locates in here. You pilot off the valve guide. And this thing has a U-axis, so this is basically a lathe. It's doing the contour. That's why they call it a contour. It's doing
Is
the
it like
contour of the
feeds?
Yes.
Okay. It's like a feed out head for a mill. Those old like
yes, exactly.
boring heads.
When we cut the seats, we can put a radius. We can do whatever we need. We can get everything to blend nicely.
Right.
I mean, look at all that in
Yeah,
there.
because you can't mill that.
I mean, look at the rainbow in there.
Woo! Beauty. Boy, that's nice.
So that's these seats are cut with that. There's other, like Surdy is one of the machines. I think Rottler has a machine. They take a fixed insert, like with fixed angles. So you buy inserts that have the ground angles that you want.
Right.
And then you just come in and you plunge and it cuts, and that'll do a nice job. But we also know that when you're using a formed cutter, you can also get a little chatter.
Yep.
We want to avoid chatter, so as a single point going down in there and doing that U-axis,
Right.
we just get perfection with these.
Yeah.
And this is the line boring machine. This is the smaller one, so we do the smaller jobs on that, but there's a bigger machine if you start getting into the big blocks. And this is what we're talking about here. You set up the tool, the rod goes through here, and so these release. You put one on each side of the arm, you lock it back in, and then you just bore. So when he first sets up, he's setting up, and he's indicating both ends, and you can see all the fine adjustment that they have for in and up. Once he has everything dialed in, locks everything in place, and then does the line boring. But he'll do one journal at a time, so he's constantly moving the arms to get max rigidity right next to the journal that he needs to cut.
Got it.
This balancer, the CWT balancer, is extremely accurate. So everything we balance, let's say a 1/4 ounce is about a normal standard for balancing crankshafts. When we balance, we try to get to 0.1 ounce inch or better. And this balancer, actually the software, will give you the amount of force that you will have on your piston with a given RPM based on the imbalance that you have in that crankshaft.
Now that's that unit you just said, ounce inch. Can you explain that?
Yeah, so when you're balancing, you're measuring from center line, right? So it's ounce per inch radial. So if you're balancing at 5-inch, radial, and you have a pretty big disc, and in many cases, like on these crankshafts, if I have one over here, you'll see it. I mean, you're probably, normally about a 5-inch diameter, and you're balancing out there. So the figure, when they talk balancing, they talk about ounce inch.
Okay.
Yep.
So it's a torque, right? Foot-pounds. It's the same.
Yeah.
So, but it's such a small unit that ounce
It's a
inch.
very small unit.
Gotcha. Understand.
Very small unit. But what's amazing, what we learned from the software here is you balance a crankshaft to a 1/4 ounce inch, and maybe at 6,000 RPM you're good. Like the lowest revving RPM of a BMW engine, modern BMW engine, especially if it's normally aspirated, is really like 6,000 RPM. But we do build some engines that are revving 9,000, close to 10,000, 9,500 is not uncommon in some of these engines. So what happens is that force starts to become exponential.
Yeah, it's V squared over R, right? It's radial acceleration.
Starts to become exponential. When they give you that figure in pounds, it just really lights up your eyes. So it goes something like a minor difference from a 1/4 ounce to 0.1 could be maybe 100 pounds versus 200 pounds.
Oh yeah. Yeah, when it's squared, it gets crazy.
So we love this balancer.
Yeah, that's cool.
And so really this is, there's an engine that's that has to be line bored, because that particular one over here, you can see they've already, so what you have to do when you go to line bore, what they've determined is that one of these, I think one of the middle ones, was about 2.5 thousandths too loose already, so kind of elongated. So we set that up on that resurfacer, and we took about 4 thousandths off. Then this will bolt back onto here, and then after it's bolted back on, then we'll set up and we'll line bore, and then because you're 2.5 too large, you take 4 off. Now you should technically have about 1.5 thou too tight. So then you set up and you line bore it and you get everything in perfect line. This is a little 4-cylinder for like a Mini Cooper that's going back together. So what's left is that cylinder head that you saw over there. That'll go on next. After they assemble that cylinder head, that'll go on.
Yep.
But yeah, you could see some of the cleaning that we do, like the wet blasting and everything like that. We turn an old engine. I mean,
this was an old engine in a car?
Yeah, this one is probably like from they don't have the year, but this was probably from like a 2012 or something like that. So
yeah, enough time to get caked in dirt and grease.
Well, yeah, I mean, to give you an example, look at this, right?
Right.
Yep. Yeah. So I hope this was good.
Yeah, no, this is very cool. I'm like familiar with this stuff, just to know that it exists, but to actually see it and get a better understanding of it, it's pretty cool.
Mm-hmm. Let me show you that block. This is like one of the older M5 engines, what they call the S62. So this engine was done as a demo engine, so everything is overcut for ease of removal. But in theory, what you have here is the step will be cut as a smaller step. And so when you're looking at these engines, I need a little screw or something to be able to get the guys in there. And that'll let me just get in here and lift that out. So this was, all the way up to here, right? Obviously, but it was one channel, and then coolant flows through that. So when we machine, and then we put these in with a press fit, that ends up holding the cylinders. Once the head is bolted on, it ties everything together, and the cylinders can't float a little bit. So when they don't have any support, although they're kind of Siamese and touching each other, they can still float and still have some movement.
Okay.
So
Interesting. Yeah, there's a lot of thought that goes into all this stuff.
yep. This is actually a nice little lathe, but this doesn't get used very much because we have the Integrex and we have a 250 MSY as well. But I think I'm going to put this up for sale. This is a very low hour, you know, Haas GT20. It's got the tool changer on it. It's got a bunch of spindle liners. So it's a neat little machine that
Do you know
I think.
how much you want for it?
I think we're probably with the liners and everything, 20 are negotiable.
Cool.
You know,
Looks like it's in great shape.
it's an excellent condition. It's very, very low hours.
Yeah. Got the coolant pump with it.
Yeah.
Cool.
Yep, with that, and it's got the bunch of liners, like I said, that goes with it. There might be some other, you know, there you go, as well. That's part of it. So we have an old Charmilles Robofill. We never put this thing in operation. We bought it from an auction. So this is something that we would like to move because this is not,
Yeah.
you know, in our wheelhouse really.
So if somebody wants it,
Yep.
make them an offer.
Yep. This is an older compressor that's, you know, available. A big old dryer if somebody's interested. That white cabinet's small. Probably, you know, if somebody's a hobbyist, that would be a nice glass bead cabinet as well.
Yeah.
This is a really high quality compressor, and also has very low hours, really good condition.
We're gonna sell this.
Yep, I want to sell it because we have 2 screw compressors, and I don't think there's a need to hold on to yet another compressor. You know, so
Yep.
that's that. This is something that is we rebuilt this compressor, so it's got all new valves and everything is done with this one. So this is available pieces. Then what we have kind of hiding around back. That email is available. This frame machine is available. When we bought it, we were looking to do, you know, expand the body shop, but we've since, you know, did a little U-turn with that and leased that out. So we have this machine that will be available. This is a cheap, easy liner, so it's a super quality machine. But this is pretty large, so this will actually do trucks and, you know, dualies and whatever else can easily fit on this machine and can be pulled.
Yep.
What we have kind of hiding over here, we have all our trade show equipment, but this Quest, this Hardinge, we actually had it commissioned even. It's not like it went without being commissioned. We actually commissioned this guy.
Meaning you checked, verify the accuracies.
Yeah, meaning like the Husserger came out and, you know, this was sitting where the Integrex was sitting.
Okay.
And so this is a super precision. It's got 16 turret positions. It's got live tooling. Nice, you know, really nice machine. Low hours, I think, going. I can look up the records, but I think it has 3,000 hours or something like that. It came out of an R&D facility.
Cool.
I will take a bath on it. I will absolutely take a bath on it because I paid a premium because I wanted it. And, you know, sometimes when you want something, you pay a little bit more just to have it. But once we got, you know, the Integrex, or let's say once we got that MSY 250, the Quick Turn, that was a little bit easier because now people, 2 lathes, same control,
Sure.
a little bit easier. So
Yeah. So this is the super precision,
super precision.
which means it's
Microns.
a granite casting.
I think it's in the casting and it's in the scales, I believe.
Okay, probably linear scales.
I mean, they talk about this thing repeating tenths all day long.
Wow.
Yeah.
That's awesome. Yeah, I don't know much about them, but every once in a while I hear somebody mention one.
Yeah.
So this one was made in Elmira then?
Yes.
Okay.
Absolutely. It was a 2003 that were. I just don't know when they cut off, and I don't. You know, there's. Yeah, it's got the chip conveyor with it, and everything is pretty darn clean. For 2003, it's a super nice machine.
All right, well, I think we covered it pretty good. I appreciate your time. Thanks for opening up and letting us see what you guys do here. It's
Yeah, my pleasure.
awesome to share it with us.